Hello and welcome to another TensorFlow tutorial. Today I will just be showing you guys how to actually use the custom dataset that we made in the last video. And yeah, let's get right into it. I'm gonna be using a functional model. Just gonna have to import a few libraries here quick. Uh, uh, gonna im uh, gonna import Keras, and we're also gonna import layers from Keras. So TensorFlow.keras import layers. This will just help us save a few keystrokes. We don't have to type out everything, right? So we're just gonna want to initialize our input layer. So from last video, we know that the shape was 64 by 64 by 1 because 1 indicates that it's grayscale, MNIST is grayscale. And this dataset that we're using is grayscale as well, so we're going to start off with a conv2D layer. I think this architecture is basically the same as the convnet tiny, so just going to be using that. So kernel size, we're going to set that to 3, padding equals same inputs. We have to put layers there. So yeah, we first initialize the layer and then we put the inputs next to it. We call it by putting the inputs in brackets next to it. Then after that, we're gonna have to just add a batch normalization layer, and we're gonna put x into that. So we're gonna call it by inputting the parameter x, which is our data. Then gonna have an activation function, which is really, and we don't have to initialize this. We just have to call it. This is nice. And then we'll just do the same block as before. Conv2D filters equals, we're gonna use 64 filters this time. Then kernel size will be the same. And padding is equal to same again. And then we're just gonna go x. X is equal to, we're gonna just using the same block from up top there, normalization. And then, wait, we've got an x there. Can't mess that out, that's very important. Then we want to make an activation function again, which is really pass in x. Then afterwards we're gonna max pool this. So layers dot max pool 2D. Obviously we don't have to set anything here because it seems like the default values is 2 and there's no strides. The padding is valid. That's what we want. And then after max pooling, we're gonna do another 2 conv layers. So layers.conv2d. Gonna do 64 filters again. This equals 64. Why is everything? Okay. Kernel size equal to 3, comma. And then padding equals same. Then I'm just gonna input x into that again, and then another kernel, as I said, another convolution layer. 2D filters equals 128. Kernel size equals 3. Padding same. Just good practice typing everything out. Just let everything sink into your brain, and we're gonna do another max pooling layer. Layers.max pooling 2D. Don't have to set anything because the default parameters is what we want. X equal to, so now we're gonna flatten it so we can pass it into a fully connected layer, or as TensorFlow denotes it as a dense layer. So let's flatten it quick. Flatten X, and then we'll do another layers equals layers dot flatten. Sorry, not sorry, layers dot dense. And how many nodes we're gonna have? Let's say 128 activation. We're gonna make this relu again. Right, then we go. Need to put X there. Yeah, you see, when PyCharm highlights this, you can see there's an X missing. So yeah, X. And then you can see over here. Well, it's not anymore. It seems like we haven't left anything out. Alright, then we're going to add a dropout layer for regularization. Layers dot dropout, and then we're just gonna set that to 0.5. After that, oh yeah, we need to add X there. We can't forget that. And lastly, let's just put this into one block. We'll add another dense layer. Not lastly, but close to last. Dense, and then we're gonna have 64 nodes instead. We'll have another relu activation equals relu. Let's pop layers there. Then obviously X at the end. Alright, and then so since we're gonna have to output two different for two different numbers, we're gonna have two different outputs. And here's where the trick comes in, that we had to define, well, with the dictionary we had to define the first number and the second number at the top here, which is over here. So this is going to correspond to the first number, the first output and the second output, and we actually have to name the dense layer after this label or this key. So layers dot dense 10 activation equals softmax, since it's going to be multi-class classification. Name equals first num. X output 2 equals layers dot dense 10 activation equals softmax. Just doing exactly the same thing for the second number output, second num. Then we're taking X as well. Cool. Alright. I think that's everything. And now we can create our model from the inputs and outputs. So we go curious dot model dot inputs equals inputs and outputs equals not outputs but output 1 and output 2. Easy as that. After that, let's compile our model. Compile optimizer equals t or curious dot optimizers dot atom. Atom is safe, so we'll just use that, and then curious dot losses dot sparse categorical. Get the sparse categorical cross entropy. It's making me type out this entire thing. Metrics equals, we're just gonna go with accuracy. It's only the metric that we really care about here. So let's just fit model dot fit train ds comma epochs equals 5 verbose. We're gonna leave that verbose actually. No, we'll actually set it so we can change it later. We're gonna set this to 1 though. Alright, it seems like everything should be working. Just double check that. Actually, we can just run it, see what happens. Seems like it errored out, it says no module. Yeah, let's just replace curious with TensorFlow at the moment. I've had this error before and it seems like it's just doesn't want to go away. So and take out this. Alright, cool. Let's try this again. PyCharm isn't complaining now. What is it complaining about? Then what's this one? Yeah, that's fine. Yeah, that's supposed to be activations. Cool, that's activations. Let's try that again. Alright, so yeah, I let it train for a bit and I was actually observing it and it seems like the loss isn't going down that much and I'm not sure why. I need to investigate it a bit more. But after investigating, I'll get back to you guys on. Alright, cool. So I managed to figure out the error. It was because we weren't actually normalizing the data. So to normalize the data, we're just gonna have to get it to a range of between 0 and 1. Right now it's at a range between 0 and 255. So we're just gonna have to divide by 255 to get it to that range. So let's just take this x is equal to inputs. Actually, we'll just go inputs equal to inputs. That no, we shouldn't overwrite that. So x equal to inputs divided by 255.0. Yeah, so just gonna put that over there so that it's working. One thing to note is that I think you should rather do it while you're pre-processing, so you're resizing the image. So you should rather put it over here for the time being. We'll just put it down there because I've already completed this video. Can't really change the code there. Okay, then everything should be working fine. Let me just run this. Also, oh wait, let's just change this to 3 epochs so I don't have to wait for that one. Right. I'm just double checking everything. Okay, yeah. Yeah, I'll get back to you guys when, is this even X? Yeah, it is. Okay. I'll get back to you guys when it's done training. Alright, cool. So yeah, you can see after just 3 epochs, the accuracy is actually at 86 and 83%, which is pretty good. Yeah, so that's how you basically implement a model using the custom dataset that we just used with 2 different outputs. Right, I hope you enjoyed the video. Please don't forget to like if you did like the video and subscribe if you want to see more content similar to this. Bye.